I welcome you all to K-Tech High School and Junior College. Good morning. This is not just a greeting, it signifies a hope that the beautiful morning will bring a smile on your face and happiness in your life. As you all know, we have started with our lesson number 4, current, electricity and magnetism. So what is it? A flow of charge from 1 ampere to another is called electric current. The unit is ampere, which is equal to the flow of 1 coulomb per second. Potential difference or voltage is the difference in electric potential energy per unit of charge measured at 2 points. The symbol for potential difference or voltage is V and the unit is volts. And electric potential, it is the amount of work done in bringing a unit positive charge from infinity to a given point in the electric field. It is a scalar quantity and SI unit is joules per coulombs or volts. In today's session, we will be learning about dry cell, lead acid cell, electric circuits and connecting cells. The first in the row we have dry cell. Dry cell was invented by Leclanche, a French scientist in the year 1866. It contains a cylindrical zinc container which forms the negative electrode. The electrolyte is a mixture of ammonium chloride and zinc chloride paste. A carbon rod surrounded by manganese dioxide acts on the positive electrode. Dry cell is portable and very convenient to use. So, this type of cell is used in torches, radios, and other small electrical devices. Local action and polarization is remedied in a dry cell. Carbon rod is surrounded by hydrogen formed during the reaction in a dry cell. The action of manganese oxide MnO2 is comparatively slow and this is called slow depolarization. If the cell is used continuously for a long time, polarization eventually sets in due to accumulation of hydrogen on carbon rods and the cell actions stops. For this reason, the cells are not used for continuous work. When allowed to rest, the accumulated hydrogen is oxidized to water and by the manganese dioxide and the cell is again ready for the use. Are you getting me, children? Let's see the advantages of a dry cell. They are compact and portable and very convenient in size. They do not contain any liquid which can spill. It is cheap. Disadvantages of a dry cell. The cell is subjected to polarization. The cell produces only intermittent current. Now let's see about the lead acid cell. Working of lead acid cell or battery. This is the very commonly used as a storage battery or secondary battery. Before going to the working principle, we should know about the materials used for lead acid storage battery cells. The main active material required to construct a lead acid batteries are lead peroxide, sponge lead, and dilute sulfuric acid. The positive plate of lead acid battery is made up of lead peroxide. This is dark brown, hard and brittle substance. The negative plate of a lead acid battery is made up of pure lead in soft sponge condition. Dilute sulfuric acid used for lead acid battery has ratio of water is to acid equal to 3:1. The lead acid storage battery formed by dipping the lead peroxide plate and sponge lead plate in dilute sulfuric acid. A load disconnected externally between these plates. In dilute sulfuric acid, the molecules of acid splits into positive hydrogen ions and negative sulfate ions. The hydrogen ions, when reach at lead plate, peroxide plate, they receive electrons from it and become hydrogen atom, which again attack the lead peroxide and forms lead oxide and water. This lead oxide reacts with sulfuric acid and forms lead sulfate and water. Are you getting me, children? Now, negative sulfate ions are moving freely in the solution. So, some of them will reach to pure lead plate, where they give their extra electrons and become radical sulfate. As the radical sulfate cannot exist alone, it will attack pure lead and will form lead sulfate. As positive hydrogen ion takes electron from lead peroxide plate and negative sulfate ion gives electrons to lead plate, there would be an inequality of electrons between these two plates. Hence, there would be a flow of current through the external load between these plates for balancing these inequality of electron. This process is called discharging of lead acid batteries. Now we will learn about the electric circuits. These are the symbols denoting electrical component used in a circuit. This is the symbol representing a battery, which is a 1.5 volt cell. The bigger line represents a positive terminal and the smaller one represents the negative terminal. This symbol is used to bulb connected in the circuit. It is just W written upside down in this way and enclosed in a circle. So if we want to draw a simple circuit using these symbols, then how do we do it? Just draw the symbols for electric cell and bulb first. Then, using straight lines for the wires, join them together. This is the circuit diagram representing this circuit. It was simple to draw, isn't it, children? You can even show the direction of electric current in the circuits with the arrowheads. So, the electric current is flowing in this direction from the positive to the negative terminal of the cell. Now, we have seen in the past that this is not only the way to light up a bulb in the circuit. For instance, if we interchange the wires connected to the two terminals of the bulb, then the bulb will still glow. This is because the circuit is still complete and all the terminals of the circuit is occupied. Can you draw a circuit diagram for this circuit? Why don't you give it a try? If you look at this circuit, the positive terminal of the cell was initially connected to this terminal of the bulb and is now connected to the other terminal. Similarly, the negative terminal, which was initially connected to this terminal, is now connected to this one. So how will the circuit diagram of this circuit look like? This is the circuit diagram. Compare it with this one. You will see that we have just reversed the direction of the battery. Hence, the electric current in this circuit is flowing in the opposite direction. So, the electric current can flow in either direction. As long as the circuit is complete, the electricity will flow and the bulb will glow. Let us look at this circuit now. How many components does this circuit has? Yes, 3. A bulb, a switch and a cell. What is the symbol for switch? There are two symbols for the switch. This symbol is used when the switch is on and this symbol is used when the switch is off. If we would to draw a circuit diagram for this circuit, then here it is, what it will look like. Note that there will be two circuit diagrams for this. This is when the switch is off and the electric current is not flowing through the circuit. We see that no arrowheads are shown here. And this circuit diagram is when the switch is on. Here the circuit is complete and the current is flowing. The arrowheads are used to show the direction of electric current, which is always from positive terminal to the negative terminal of the battery. Now here is the question for you. We know that when the electric current flows between the two ends of the filament and the filament heats up. This heating up of the filament results in glowing, and this is how we receive light from the bulb. But if this filament is broken, then will the bulb glow? No, it won't. This is because if the filament breaks, the circuit will be broken. Understood? Let's learn about connecting cells. Take two 1.5 volt electric cells. The region with the metal cap is the positive terminal of the cell, and on the opposite side, the region with the flat metal base is the negative terminal of the cell. Join one positive terminal of the cell to the negative terminal of the other using an electrical tape. This is called a battery. A battery is a combination of two or more electric cells connected together in a series combination or a parallel combination. What are these combinations? Well, if the cells are connected as shown with their opposite terminals connected together, then we will say it is series combinations of the cells. We simply say that the cells are connected in series. Parallel combination is when the positive terminals or the negative terminals of the cells are connected together. However, we will learn about the series combination of cells. In everyday life, we call this single cell a battery. But in physics, a battery is the combination of more than one cell. So this is a battery with a positive terminal on one side and negative terminal on the opposite side. We can even connect more cells to the system, but always make sure that the positive and the negative terminals are connected together. Even if four are connected together, it will still be called a battery. Now let's talk more about a battery. What is the voltage of a battery of combination of two cells? Well, if the cells are connected in a series, then their voltage is added up. This means that the voltage of this battery will be 1.5 volt plus 1.5 volt. What will this be equal to? It will be 2 times of 1.5 volt, which is equals to 3 volts. So, this battery is twice as strong as one of the individual cell of the battery. But wait, it does not mean that this battery will last twice as long. So what does it imply? We first need to understand that the different devices require different voltage power sources for functioning. A torch bulb in our torch requires a 3 volt battery to light up brightly. This is why the series combination of cells is used to the torch. You must have also seen a battery compartment in the devices in this shape. How do we insert cells in this cell holder? Yes, we compress the spring by inserting the negative terminals of the cell. What is this spring made up of? it is made up of metal and hence it conducts electricity. On the opposite side, the positive terminal of the cell is also in contact with some metal thing. In the same way, we insert the second cell. But are the cells connected in a series combination here? Looks like a parallel combination, right? But no, they are in a series combination. If we look carefully, on one end inside an empty cell holder, we will find a thin metal wire or a metal rod connecting the positive terminal of one side with the negative terminal to the adjacent side. So that this is how the cells inside the containers are connected in a series combination. Got it, children? Good. Now let's take a look over the summary. A dry cell. The dry cell battery is most commonly used for radios, torches, etc. The zinc cup forms the negative terminal of the battery while the carbon rod is the positive terminal. In between the two terminals is a paste of ammonium chloride and completes the circuit by allowing ions to flow through it. Lead acid batteries are made up of lead plates, lead oxide with 35% sulfuric acid and 65% water solution. The solution is called electrolyte, which causes a chemical reaction that produces electrons. Electric circuits. An electric circuit is a conducting path through which electric current can flow. Electric current must be the same at all points in a simple single loop circuit. Charge can never be created or destroyed. All the charge that flow through one point in the circuit must flow to the next point also. Cells in series and parallel combination. Dry cells can be connected together in two types, series circuits and parallel circuits. Series circuits. The advantage of connecting cells in series is that it increases the electric potential, that is voltage, produced at the output terminals of the batteries. As the electron travels through the consecutive batteries, it gets an additional boost of energy, increasing its voltage. Parallel circuit is when there is more than one pathway or electrons to flow. Connecting cells in parallel does not affect the voltage as electrons will only pass through one pathway. The duration of time the load will operate will increase in relation to how many cells are in a circuit. Got it, children? Now let's see the notes for today's topic. As we know, we all write first the new words followed by the glossary, the scientific meanings of the words. Question number 1. Choose the correct option and fill in the blanks. Question number 2. Match the following followed by answer in one sentence each. Then we have question number 4. Answer in brief. Please draw this diagram also, children. The answer in brief, you need to write the construction of a dry cell, working of a dry cell and usefulness of a dry cell. And the last question, distinguish between dry cell and lead acid cell. Please maintain the notes properly, children. Thank you, my dear children. I hope you have found this lecture very interesting. We shall see you in the next lecture. Till then, take care. Thank you once again.